Welcome children. In this video we are going to see about the product of two vectors, scalar or dot product of two vectors. So multiplication of two vectors or product of two vectors is also defined in two ways, namely scalar or dot product and vector or cross product, where the result is a vector. In a scalar or dot product, the result is a scalar. So what is scalar or dot product of two numbers? The scalar product of two non-zero vectors a and b denoted by a dot b, which is equal to magnitude of a into b cos theta, where theta is the angle between a and b. Theta lies between 0 and pi. If either a equal to 0 or b equal to 0, then theta is not defined. And in this case, we define a dot b equal to 0. So scalar or dot product of two vectors, a dot b equal to magnitude ab into cos theta. Observations: a dot b is a real number. Second one, let a and b be two non-zero vectors, then a dot b equal to 0 if and only if a and b are perpendicular to each other. If and only if the two vectors a is perpendicular to b, then a dot b equal to 0. Third one, if theta equal to 0, then a dot b equal to magnitude of a into magnitude of b. Cos 0 is 1. So a dot b equal to a into b. In particular, a dot a, which is equal to magnitude of a square, as theta in this case is 0. A dot a equal to a square. Fourth one, if theta equal to pi, then a dot b equal to minus of a into b. So cos pi is minus 1. So it will become minus of a into b. In particular, a dot minus a, which is equal to minus of a square, as theta in this case is pi. Then fifth one, for mutually perpendicular unit vectors I, j and k, we have I dot I, which is equal to j dot j, which is equal to k dot k equal to 1. I dot j equal to j dot k equal to k dot I, which is equal to 0. Sixth one, the angle between two non-zero vectors a and b is given by a dot b equal to ab cos theta. So from this, cos theta equal to a dot b by modulus of a into b, or theta equal to cos inverse of a dot b by ab. Properties of dot product. First property, dot product is commutative, that is a dot b equal to b dot a. Next one, scalar product is associative with respect to a scalar, that is lambda of a dot b, which is equal to lambda of a dot b, which is equal to a dot lambda of b. Third one, dot product is distributive. That is A dot B plus C, which is equal to A dot B plus A dot C. If two vectors A and B are given in component form as A1i plus A2j plus A3k and B1i plus B2j plus B3k, then the scalar product is given as A dot B equal to A1i plus A2j plus A3k dot B1i plus B2j plus B3k. On simplifying this, we get A1 B1 plus A2 B2 plus A3 B3. Projection of a vector on a line. Suppose a vector AB makes an angle theta with a given directed line L in the anticlockwise direction. Then the projection of AB on L is a vector P with magnitude AB cos theta, and the direction P being the same or opposite to that of the line L, depending upon whether theta is positive or negative. So vector P, which is called the projection vector, and its magnitude P, which is called the projection of the vector AB on the directed line. If theta equal to 0, then the projection vector of AB will be AB. If theta equal to pi, then the projection vector of AB will be BA. If theta equal to pi by 2 or 3 pi by 2, then the projection vector of AB will be the 0 vectors. Projection of A on other vector B, which is given by A dot B cap, which is equal to A dot unit vector is vector B by magnitude of B, which is equal to A dot B by magnitude of B. So projection of A on B is A dot B by magnitude of B. Projection of B on A is A dot B by magnitude of A. If alpha, beta and gamma are the direction angles of the vector A equal to A1i plus A2j plus A3k, then the DCs may be given as cos alpha equal to A dot I cap by magnitude of A into I, which is equal to A1 by magnitude of A, cos beta equal to A2 by magnitude of A vector, and cos gamma equal to A3 by magnitude of A vector. If A is a unit vector, then it may be expressed in terms of a direction cosines as A vector equal to cos alpha I plus cos beta j plus cos gamma k. Exercise 10.3, first question, find the angle between two vectors A and B with magnitudes root 3 and 2 respectively, having A dot B equal to root 6. Here it's given that magnitude of A is root 3 and B is 2, A dot B equal to root 6. We have to find the angle between A and B. A dot B, which is equal to magnitude of A into B cos theta. So cos theta, which is equal to A dot B by magnitude of A into B, which is equal to root 6 by root 3 into 2. So cancelling this, root 2, which is equal to 1 by root 2. So cos theta equal to 1 by root 2, then theta equal to cos inverse of 1 by root 2, which is pi by 4. So theta equal to pi by 4. Second one, find the angle between two vectors I minus 2j plus 3k and 3i minus 2j plus k. So let A equal to I minus 2j plus 3k and B equal to 3i minus 2j plus k. So we need to find the angle between two vectors. So cos theta is A dot B by magnitude of A into B. So this A equal to root of 1 square plus minus 2 whole square plus 3 square, which is 1 plus 4 plus 9, which is root 14. And again magnitude of B is 3 square plus minus 2 whole square plus 1 square, which is equal to 9 plus 1 plus 4, which is root 14. Then we need to find A dot B, which is equal to I minus 2j plus 3k dot 3i minus 2j plus k. So 1 into 3, I dot I is 1, and again I dot j is 0 and I dot k is 0, I dot I is 1, j dot j is 1 and k dot k is 1. So 1 into 3 is 3, minus 2 into minus 2, which is plus 4, plus 3 into 1 is 3, which is equal to 10. So cos theta equal to A dot B by magnitude of A into B, which is equal to 10 by root 14 into root 14. Cos theta equal to 10 by 14, so 5 by 7. Theta equal to cos inverse of 5 by 7. Third one, find the projection of the vector I minus j on the vector I plus j. So projection of A on B is A dot B by magnitude of B, which is equal to I minus j dot I plus j. So product of two vectors. So I dot I is 1, I dot j is 0. Similarly j dot I is 0, j dot j is 1. So we have to multiply I dot I, which is 1, 1 into 1 is 1, minus j dot j, that is minus 1 into 1, which is minus 1, whole by magnitude of B, which is 1 square plus 1 square, which is root 2, which is equal to 1 minus 1 is 0. So projection of A on B equal to 0. So fourth question is find the projection of the vector on the another vector. So it's similar to third question, you can do on your own. Then fifth one, show that each of the given three vectors is a unit vector. 1 by 7 2i plus 3j plus 6k, 1 by 7 3i minus 6j plus 2k, 1 by 7 6i plus 2j minus 3k. Also show that they are mutually perpendicular to each other. So three vectors are given, we have to find the magnitude of three vectors, and then we have to show that they are mutually perpendicular to each other. That is, if they are perpendicular to each other, then A dot B equal to 0. We have to prove A perpendicular to B, B perpendicular to C, and C perpendicular to A. So let's find first the magnitude of A, which is 1 by 7 root of 2 square plus 3 square plus 6 square. So 36 plus 4 plus 9, which is 49. So root 49 is 7. 7 by 7 is 1. Then magnitude of B, which is equal to 1 by 7 of root 3 square plus minus 6 the whole square plus 2 square, which is same root 49. So 7 by 7 is 1. And magnitude of C, which is equal to 1 by 7 root of 6 square plus 2 square plus minus 3 whole square, which is root 49. So 7 by 7, which is also equal to 1. Hence we have proved that the three given vectors is a unit vector. Now we have to show that they are mutually perpendicular to each other. So A dot B equal to 1 by 7 of 2i plus 3j plus 6k dot 1 by 7 of 3i minus 6j plus 2k, which is equal to 1 by 49, 6, 2 into 3, 6, j into j, 3 into minus 6, which is minus 18, 6 into 2, which is 12. So, which is equal to 0. Since a dot b equal to 0, a is perpendicular to b. Then b dot c, which is equal to 1 by 7, 3i minus 6j plus 2k dot 1 by 7 of 6i plus 2j minus 3k, which is equal to 1 by 49 of 18 minus 12 and minus 6, which is 0. So, b dot c equal to 0, then b is perpendicular to c. Now, c dot a, which is equal to 1 by 7 6i plus 2j minus 3k dot 1 by 7 of 2i plus 3j plus 6k, which is equal to 1 by 49, 6 into 2, 12 plus 2 into 3, 6 minus 80, which is equal to 0. So, c dot a equal to 0, and we can say that c is perpendicular to a. Hence, a, b and c are unit vectors and are perpendicular to each other.